and welcome everyone. My name is Carol Armstrong and I will be hosting this Delabie webinar. Delabie are the European market leader for water controls and sanitary ware in healthcare facilities. Before we start, let me explain how the tools work so you can interact with us during the webinar. On the right of your screen you have two options, chat and questions. Feel free to use the chat option throughout the presentation. The team at Delabie will also join us via this option. In the questions option, you can ask any questions and our experts will reply to them individually. At the end of the webinar, we will pick up and answer the most frequently asked questions live. Today, we are joined by Professor Hartmann, Emeritus Professor of Public Health, and Sébastien Jeux, UK Sales Director. Let's remind ourselves of the webinar topic. Healthcare facility water systems. How can we control the risk of bacterial development and remove the risk of scalding? We know that at some point, many healthcare facilities will face the problem of bacterial development in their water distribution system. Professor Hartmann, you have recently published a scientific article in the French magazine Hygiene S. We often hear about Legionella and nosocomial infection. Can you tell us more about these problems?
With pleasure. Over time, a natural film develops in water distribution systems with lines inside of the pipes and taps with the salt contained in the water. When bacteria are attaching this film, we call this a biofilm. Bacteria can occur naturally in water, and when they are attached to this biofilm, they are finding ideal conditions in terms of moisture, temperature, and nutrients for their development. If it's not monitored and controlled, bacterial development in the water system can become very problematic. The water quality is at risk of deteriorating, not only chemically, but also at a microbiological level. Waterborne pathogens such as Legionella pneumophila and Pseudomonas aeruginosa will develop. These opportunistic pathogens will then proliferate right inside the biofilm and the amoebae in the water distribution system. They attack immunosuppressed patients through different ways. Oral way, for example, or an inhalation, for example, for Legionella, when a man is taking a shower, or for Pseudomonas aeruginosa, by direct contact between contaminated water and open wounds or burns, or with a medical instrument that has been contaminated by water from the system.
Can you tell us a bit more about how these bacteria develop?
There are many factors that encourage proliferation. First of all, let's look at water stagnation. It's one of the main sources of bacterial contamination in the water system. It's often associated with infrequently or unused point of use, particularly isolated sinks, unoccupied rooms located at the ends of a corridor, or even wash basins, which are rarely used for hand washing now due to the prevalence of hydroalcoholic gel. Another example of stagnation is what we call dead legs. They are those parts of the system where the water no longer circulates. For example, if showers or hand wash basins have been decommissioned without removing the associated pipes upstream. All the unused installation can eventually lead to contamination in the pipes and taps. Another factor which favors proliferation is not maintaining the hot water at a high enough temperature in the system. In the UK healthcare facilities, hot water should be maintained at or above 55 degrees Celsius and 50 degrees Celsius in all other buildings. To be more precise, above 50 degrees, Legionella bacteria cannot develop, and above 60 degrees, they will be destroyed. However, if the water temperature falls below 50 degrees Celsius, the installation is at risk. I cannot go into all the detail here, but there are other factors such as scale or a large number of impurities in the hot water production and storage equipment and pipework, as well as non-return valves that are no longer watertight, and even cold water temperature around 30 degrees Celsius due to the poor pipework insulation. All of these can contribute to microbial proliferation. As you can see, the problem is very complex. Often when healthcare facility managers discover microbial contamination in the system, it's too late. At this point, the only solution is to replace part or all of the installation, meaning significant and costly repair work. Yet, the facilities team must also deal with the situation urgently. At the same time, they need to put in place what we call shock procedure.
What do you mean by shock procedures?
When we talk about shocks, these can be either thermal or chemical shocks.
So are these shocks really effective?
Shock treatments are not very effective and can cause damage to the distribution system if the system is not organized for supporting such shock. The only one real solution in this case is to avoid contamination and infection by waterborne bacteria is through prevention and compliance with Legionella monitoring guidelines. Designing the system in line with water safety plans, specifying appropriate tapware, and regular maintenance are the best means for guaranteeing water remains uncontaminated. But it is also essential to monitor high-risk point of use, to keep a record, and once again, to comply with the guidance, which is not only essential in public buildings, but also effective. And if it is a contamination episode, the team must know how to detect it quickly and intervene as quickly as possible to return the situation to normal before it's too late, especially if an intervention is required, which often takes time. Best practice is now well established, but the problem is that the guidance is relatively recent and many healthcare buildings were built before the latest guidance came into force. Bacterial contamination is therefore very common in healthcare setting. To conclude, if a healthcare facility is unable to meet the requirement and cannot review its entire facility, then there is no other option than to use point-of-use filters. They are the only means of delivering bacteriologically controlled water, regardless of the setting. I will even go as far as to say that 0.22 microns filter should be the standard solution for any installation and for sensitive areas in particular, and especially immunocompromised patients. They retain all microorganisms, including Legionella and Pseudomonas, given the cut-off threshold for this kind of filtration.
That seems very clear. Thank you, Professor Hartmann. Now, Mr. Jeux, we have seen that healthcare facilities should comply with the guidance to prevent bacterial development. What solutions does Delabie have to help healthcare facilities?
So first of all, I think we need to look a little closer at the guidance that Professor Hartmann has referred to. It has changed significantly in recent years, particularly in Europe and in the UK and France especially, where we have seen an increase in the guidance and regulations about how to control water quality in healthcare facilities. So if we take the example of the Health and Safety Guidance HSG 274 Part 2, that relates to Legionella monitoring, it recommends monitoring sentinel points in all public buildings, including healthcare facilities. Also, the Health Technical Memorandum 0401 Part B, that has been published in 2016, requires that the control protocols are monitored and maintained as identified in the risk assessment and water safety plan for both hot and cold water systems. Also, this guidance recommends installing taps that can be removed easily to be cleaned and disinfected. So at Delabie, we don't just offer solutions that comply with the guidance and response to the challenges of Legionella and Pseudomonas. We go even further.
What does that mean?
Okay, so let's take the French medical standard of 2017 concerning tapware in medical facilities. This standard banned EPDM flexibles and aerators in healthcare facilities in France. So Delabie anticipated this standard following the alert of the UK Department of Health in 2010 regarding the use of EPDM flexible hoses. And since then, Delabie offers mixers with copper tails or PEX flexibles as standard. In addition, our mixers and taps are fitted with flow straighteners that have been specifically designed for healthcare facilities, and some are even equipped with the BioSafe free flow outlet, which has a smooth interior with nowhere for impurities or scale deposits to adhere. So another very important point is that the French medical standard requires that mixers have an inlet shut-off point upstream of the mixing chamber. So in simple terms, it means that we need solutions without non-return valves. And this is really interesting, as we know that non-return valves present a higher risk and can be even the source of bacterial development. And because of defective non-return valves, there have already been many deaths in the hospital environment.
So does that mean non-return valves are responsible for bacterial development?
No, not exactly. That's a very important point. Non-return valves themselves do not cause bacterial development, but they can be the source of bacterial development if they don't work properly. Let me explain. As you know, a non-return valve is a mechanism which opens and closes to let water flow in one direction and not the other. So typically, non-return valves are used to prevent hot water flowing back into the cold water supply or vice versa. This cross flow is very dangerous because warm water can create the ideal conditions for bacteria to proliferate. But during their lifetime, non-return valves may fail because of scale built-up or impurities. That's why non-return valves must be checked at least once a year. So if we take the example of a hospital with 200 rooms, each with a basin, mixer, and shower mixer installed, it means 800 non-return valves that need to be checked every year. So realistically, this is almost impossible. That's why we are offering solutions without non-return valves and with a unique system, which means that the hot and cold water supplies can be shut off upstream of the mixing chamber.
That's really interesting. So what else does the guidance say?
Remember that our solutions are designed to prevent bacterial proliferation because, once again, prevention is essential. It's important to understand that taps do not kill bacteria, but they can prevent the development. So, at Delabie, we offer solutions to prevent bacteria and biofilm developing in the system. HTM 0401 recommends using taps that can be removed easily for disinfection and to remove the biofilm. At Delabie, we developed our BioClip solution a long time before this guidance. These are mixers with removable spouts and mixers that can be removed completely for deep internal cleaning. Professor Hartmann has just reminded us how important it is to fight against water stagnation, and in certain countries, Germany and in the UK included, require the system to be flushed regularly. This is possible with our electronic taps that have an antibacterial duty flush, which activates automatically 24 hours after the last use. So the valve opens automatically for 1 minute to flush the pipework and rinse the mixer to prevent water stagnation.
You really do have a lot of solutions. No non-return valves, removable mixers, automatic duty flush. The list is long. What other solutions does Delabie offer?
We've talked a lot about basins and showers, but if we now take the example of cistern flushing toilets, we come back to the same problem of water stagnation. Remember that the inside of a toilet cistern is covered with biofilm. The cistern interior has a large surface area, and it contains stagnant water, which is in contact with air. So this constitutes a major risk of bacterial development, which will then spread into the system. To support this, a study recently published in the French Hygiene magazine revealed that Legionella can develop very easily in the toilet cistern. It actually developed in some hospitals via their toilets. So at Delabie, we have an excellent technical solution to deal with this problem. It's called direct flush valve, and it works without a cistern. So with no cistern, there is no stagnation. The water does not come into contact with air before flushing, so there is no risk of bacterial development at this level. Many hospitals have already opted for a direct flush system without a cistern, and this trend continues rapidly. Another advantage of Delabie's mixers taps for healthcare facilities are their smooth interiors. Many mixers have a cast brass body, which is often rough on the inside. This means that there are a lot of niches where bacteria can adhere. That's why we have developed mixer bodies with smooth interiors. Another example of an extremely effective solution is to limit the amount of water that circulates inside the mixer body. This is why Delabie prefers narrower water passages, which increases the speed of water in the mixer and reduces biofilm development. Also, there is less standing water once the mixer is turned off. So once again, bacterial development is limited. This is why some of our mixers are specifically designed with small tubes inside the body. And it's a little bit like a river, actually. If you look at a river, we have perfectly clear water in the middle, but on the edges, it flows a lot more slowly. And this is where you have more flora and fauna with insects and animals. So now if you imagine a fast-flowing mountain river, it's more difficult for life to develop because there is a lot of movement and turbulence, and the speed prevents anything from attaching to the blanks. So in a tap, it's exactly the same. The speed of water circulation can significantly reduce biofilm development.
We've seen how important it is to circulate water at higher temperatures, but isn't this dangerous for users?
Yes, you are completely right. It's important to distribute water at very high temperatures to reduce bacterial development. However, there is a risk of scalding if suitable solutions are not installed, particularly for people in healthcare facilities, such as patients or residents with reduced sensitivity facing treatment, or elderly people with slower reflexes. And this happens more often than you might think. HSG 274 recommends that TMVs type 3 with an anti-scalding fail-safe should be installed at wash basins, sinks, and showers where there are high-risk users, for example. The very young, the elderly, the infirm, the mentally disabled and physically disabled people. So we need to circulate water at very high temperatures to reduce the risk of scalding and to be able to do thermal shocks. If we come back to this last point, we know that healthcare facilities are used to carrying out thermal disinfection within the constraints that we have already discussed. And in some countries, thermal shocks are obligatory. This poses an additional risk. You can imagine a situation where a thermal shock is set in place, but the user is not aware of it and takes a shower. And the hot water will immediately scald the user. This is why our hospital mixers are almost all equipped with a temperature limiter that can only be overridden by maintenance staff when a thermal shock is required.
That's very good. But how do you ensure the user's safety and comfort?
I'm coming to that. We know that many nursing homes have single feed taps installed with separate hot and cold water taps. But as we have just seen, this is not enough. Specialist controls are required in healthcare facilities, and we offer two different technologies. At first, mechanical pressure balancing technology known as EP, which compensates for pressure variations in the system and therefore the temperature changes. This usually happens when you take a shower and in the next room a patient flushes a toilet or uses cold water to wash their hands. With EP technology, you don't feel any variation in temperature. And above all, if the cold water supply fails suddenly, the hot water shuts off almost 100%, leaving only the slightest trickle of hot water. The second technology is thermostatic technology, which, in the same way, compensates for the temperature variation in the system, and also pressure variations, especially if the cold water supply fails. the hot water shuts off completely, and vice versa, if the hot water supply fails, the cold water shuts off entirely. This avoids cold showers, but also prevents a loss of balance as a result of the temperature changes. An important detail is that Delabie's products feature also a SecuriTouch technology which improves safety and removes the risk of burn when touching the shower, since the mixer has thermal insulation.
Thank you for these explanations. We are now coming to the end of our webinar. Could you summarize in a few words the essential points to remember?
Yes, absolutely. So we have seen that there are numerous factors that contribute to bacterial proliferation: stagnant water, poor temperature control, dead legs, defective non-return valves, scaled up and corroded networks, poor insulation of the cold water distribution networks, and so on. So it's essential to both follow the guidance and choose mixers which meet the specific challenges faced by healthcare facilities. The main objective is to prevent contamination in the system, because we know how hard it is to eradicate. Also, we must not forget the user's comfort and safety. And finally, remember that directors of healthcare facilities are legally responsible for the health consequences linked to Legionella and also for the patient and users' safety. So Delabie offers unique solutions in the healthcare sector and is, of course, ready to help healthcare facilities to prepare and equip themselves to face all the regulatory and safety issues.
Thank you very much, both of you, Mr. Jeux and Professor Hartmann.
Thank you very much.
Thank you.
And thank you all very much for watching our webinar as well. We really appreciate you taking the time, and we've now come to the end of the webinar, and we really look forward to seeing you again at the next of the webinar Delabie Days.